We're going to go through a titration curve, which is a graph of the pH in the beaker at different points during a titration. Our first example is of a strong acid, HCl, titrated with a strong base, NaOH, and that means the acid is the unknown concentration in the beaker, and the base is the known concentration or titrant in the burette. So when we say titrated with, the thing that we're titrating with is in the burette. The equation is HCl plus NaOH yields NaCl and water. To help us visualize what's happening in the beaker, I used circles to symbolize HCl and squares to symbolize NaOH, and I combined the two symbols for NaCl to show when the acid and base had been neutralized. The initial setup looks like the one I drew all the way on the left, with NaOH in the burette and HCl in the beaker. At this point, 0 mL of titrant have been added, so we haven't started the titration yet. On the graph, 0 mL of NaOH added is at a very low pH because it's just HCl in the beaker. When we start the titration, we'll slowly add NaOH to the beaker of HCl, which will immediately react together to make NaCl. At this point on the graph, we still have HCl in the beaker, so the pH is still very low. My second drawing from the left is at half equivalence point, which is when we've added half as much NaOH that we need to completely react with the HCl. So there's equal amounts of HCl and NaCl product in the beaker. As we add sodium hydroxide to the beaker, HCl will begin to run out and the pH will start to increase and curve upward on the graph. We'll keep adding NaOH until all of the HCl has been completely reacted. That's the equivalence point, which is shown in the third drawing. At the equivalence point, there are equal amounts of HCl and NaOH, so they react completely and only the NaCl product is left in the beaker. Because there's no more HCl, the pH jumps up very quickly on the graph, and for a strong acid and a strong base reaction, the pH at equivalence is 7. Now when we keep adding NaOH past the equivalence point, there's no more HCl to react with, so the excess NaOH will make the pH jump up even higher on the graph, and eventually it'll level out to the pH of NaOH. If you look at the last drawing of past equivalence, there's mostly NaCl in the beaker and some excess NaOH with it. So this is the titration for a strong acid and strong base. Now let's look at another example. The next example is of a weak acid, acetic acid, titrated with a strong base, NaOH. The acetic acid is in the beaker and the sodium hydroxide is in the burette. The equation is CH3COOH and NaOH yield NaCH3COO, which is the salt, and water. Now this graph looks similar to the last one because we're starting with an acid at a lower pH, and we're adding a base until the reaction is neutralized at the equivalence point, and then we'll keep adding the base until past the equivalence point. So the pH curve looks similar because we're titrating an acid with a base, just like before. There are two main differences with this graph compared to the last one. This graph starts at a slightly higher pH because acetic acid is a weak acid and doesn't dissociate very much, so it's not as acidic as HCl. The other big difference is that the equivalence point of a weak acid with a strong base is higher than a pH of 7, and we'll talk more about why that is a little bit later. But the different points during the titration are very similar to the last. We start out with just the acid in the beaker at 0 mL added. The half equivalence point will have equal amounts of acid and salt in the beaker. The equivalence point is when we have equal amounts of acid and base that will react completely, so only the salt will be in the beaker. And past the equivalence point, we'll have mostly salt in the beaker with some additional base with it. Now let's look at another example of a base titrated with an acid. In this example, a weak base, NH3, is titrated with a strong acid, HCl. So this time the base is in the beaker and the acid is in the burette. If we look at our graph, it starts at a higher pH, but this should make sense because it's the pH of just the base in the beaker by itself before any of the acid has been added. At the half equivalence point, we have equal amounts of base and salt, and the pH curve starts to become more acidic. At the equivalence point, there's equal amounts of acid and base, which are completely neutralized, so the salt is the only thing left in the beaker. And past the equivalence point, there's mostly salt in the beaker and some additional acid with it. So the curve has a similar shape, but it's just reversed because we're starting with a base at a higher pH and ending with an acid at a lower pH. The other big difference with this graph is the equivalence point of a strong acid with a weak base is lower than a pH of 7.